When working on the load side of a service and using a concentric knockout for a 1-inch EMT conduit run, a grounding locknut is indeed required. The purpose of a grounding locknut is to ensure a reliable electrical connection between the conduit and the enclosure, which is crucial for safety and proper equipment grounding. This is especially important when dealing with concentric knockouts because these knockouts can sometimes create a less than perfect electrical bond due to the way they are designed and punched out of the metal enclosure. The grounding locknut provides a secure and intentional grounding path. The National Electrical Code, or NEC, provides specific guidelines regarding the grounding and bonding of electrical systems. These codes are put in place to safeguard individuals and property from electrical hazards, such as electrical shock and fire. Proper grounding and bonding techniques are essential for creating a low impedance path for fault currents, which allows overcurrent protective devices, such as circuit breakers or fuses, to quickly and effectively clear a fault. This helps prevent dangerous voltage buildup on metal parts of electrical equipment, reducing the risk of electrical shock. When installing an electrical conduit, such as EMT or electrical metallic tubing, it's important to follow all applicable NEC requirements and local codes. This includes properly grounding the conduit system to ensure electrical continuity and safety. Grounding locknuts are one of the many tools and methods used to achieve this. They are designed to bite into the metal enclosure and conduit, creating a secure and reliable electrical connection. The use of a grounding locknut on the load side of the service, especially when using concentric knockouts, helps to mitigate the potential for poor electrical contact. It ensures that the conduit system is effectively grounded, providing a safe path for fault currents to flow back to the source. This is crucial for the proper operation of overcurrent protective devices and the overall safety of the electrical system. Always refer to the latest edition of the NEC and consult with a qualified electrician if you have any questions or concerns about grounding and bonding requirements. They can provide guidance and ensure that your electrical installation meets all applicable codes and standards. Failure to properly ground and bond electrical equipment can have serious consequences, including electrical shock, fire, and equipment damage. Taking the time to understand and implement proper grounding techniques is a critical aspect of electrical safety. In summary, the grounding locknut serves as a vital component in ensuring a safe and reliable electrical connection between the conduit and the enclosure. This is crucial for safety, especially when dealing with concentric knockouts where the electrical bond may be compromised. The grounding locknut firmly establishes a secure grounding path. Grounding and bonding are foundational elements within the NEC, aimed at protecting people and property from electrical dangers. Effective grounding and bonding establish a low impedance pathway for fault currents, facilitating the swift and efficient operation of overcurrent protective devices like circuit breakers and fuses. This mechanism prevents the dangerous accumulation of voltage on metallic parts of electrical equipment, thereby minimizing the likelihood of electrical shock. Adhering to the NEC guidelines and local regulations is paramount when installing electrical conduit, such as EMT, to guarantee both electrical continuity and safety. Grounding locknuts, among other tools, play a crucial role in achieving this. Their design ensures a firm engagement with both the metal enclosure and the conduit, thereby creating a robust and dependable electrical connection. The utilization of a grounding locknut on the low side of the service, particularly in conjunction with concentric knockouts, is crucial in addressing potential deficiencies in electrical contact. This practice ensures the conduit system is effectively grounded, thus facilitating a safe route for fault currents to return to the source. This is essential for the correct functioning of overcurrent protection and the overall safety of the electrical setup. For any uncertainties or inquiries about grounding and bonding needs, always consult the most recent NEC edition and seek guidance from a certified electrician. Their expertise is vital in guaranteeing that your electrical installations adhere to all pertinent regulations and standards. Inadequate grounding and bonding practices can lead to grave consequences, including electrical shocks, fires, and damage to equipment. Thus, investing time in understanding and executing appropriate grounding techniques is an indispensable aspect of electrical safety. Let's delve deeper into the specifics of grounding locknuts and their application within electrical systems. Firstly, understanding the purpose of a grounding locknut is essential. It's not simply a mechanical fastener, it's an electrical component designed to create a reliable, low-impedance path for fault currents. This path is critical for the proper operation of overcurrent protection devices, such as circuit breakers and fuses. Secondly, consider the design of a grounding locknut. It typically features sharp teeth or serrations on its inner surface that bite into the metal of the enclosure and the conduit. This ensures a secure electrical connection even if the surfaces are slightly corroded or painted. The teeth penetrate the surface layer to establish a solid metal-to-metal contact. Thirdly, when installing a grounding locknut, it's crucial to tighten it properly. Over-tightening can damage the conduit or enclosure, while under-tightening can result in a poor electrical connection. The manufacturer's instructions should always be followed regarding torque specifications. Fourthly, the location of the grounding locknut is important. It should be installed on the inside of the enclosure, with the teeth facing the metal surface. This ensures that the teeth bite into the metal when the locknut is tightened. Fifthly, grounding locknuts are available in various sizes to accommodate different conduit sizes. It's essential to use the correct size locknut for the conduit being installed. Using the wrong size can compromise the electrical connection and create a safety hazard. Sixthly, grounding locknuts are typically made of steel or other conductive materials. The material should be compatible with the conduit and enclosure materials to prevent corrosion. Dissimilar metals can react with each other, leading to corrosion and a poor electrical connection. Seventhly, when working with concentric knockouts, it's especially important to use a grounding locknut. Concentric knockouts are designed to be removed in stages to accommodate different conduit sizes. However, the remaining metal after a knockout is removed may not provide a reliable electrical connection. A grounding locknut ensures a solid connection, regardless of the knockout configuration. Eighthly, the NEC provides specific requirements for grounding and bonding electrical systems. These requirements are based on years of experience and research, and they are designed to ensure the safety of electrical installations. It's essential to be familiar with the NEC requirements and to follow them carefully when installing electrical equipment. Ninthly, grounding is not the same as bonding, although the terms are often used interchangeably. Grounding refers to connecting electrical equipment to the earth, while bonding refers to connecting different metal parts of an electrical system together. Both grounding and bonding are important for safety. Tenthly, regular inspection and maintenance of electrical systems are essential to ensure that grounding connections remain intact. Corrosion, loose connections, and physical damage can all compromise grounding connections, creating a safety hazard. 11thly, the use of a grounding bushing in addition to a grounding locknut can provide an even more secure electrical connection. A grounding bushing is a fitting that is installed on the end of the conduit and provides a smooth, rounded surface for the grounding conductor to connect to. 12thly, it's important to use the proper tools when installing grounding locknuts. A specialized wrench designed for tightening locknuts can help to ensure that they are properly tightened without damaging the conduit or enclosure. 13thly, when working with aluminum conduit or enclosures, it's especially important to use a grounding locknut that is specifically designed for use with aluminum. Aluminum can oxidize quickly, forming a non-conductive layer on the surface. A grounding locknut designed for aluminum will have features that help to penetrate this oxide layer and establish a solid electrical connection. 14thly, the size of the grounding conductor is also important. The NEC specifies the minimum size of grounding conductor that must be used, based on the size of the circuit conductors. Using a grounding conductor that is too small can compromise the effectiveness of the grounding system. 15thly, when installing grounding conductors, it's important to avoid sharp bends or kinks. Sharp bends can increase the impedance of the grounding conductor, reducing its effectiveness. 16thly, the grounding conductor should be connected to a grounding electrode system, which is a system of rods, plates, or other devices that are buried in the earth. The grounding electrode system provides a low impedance path for fault currents to flow back to the source. 17thly, when working on existing electrical systems, it's important to verify the integrity of the grounding system before beginning any work. This can be done by using a ground impedance tester to measure the impedance of the grounding path. 18thly, if the grounding system is found to be defective, it should be repaired before any other work is performed. A defective grounding system can create a serious safety hazard. 19thly, grounding locknuts are an essential component of a safe and reliable electrical system. By understanding their purpose, design, and installation requirements, electrical workers can help to ensure that electrical systems are properly grounded and that people and property are protected from electrical hazards. 20thly, the specific requirements for grounding locknuts and other grounding components can vary depending on the local codes and regulations. It's important to be familiar with the local requirements and to follow them carefully. The NEC serves as a baseline standard, but local jurisdictions may have more stringent requirements. In conclusion, using a grounding locknut in the scenario described is not just good practice, it's an NEC requirement meant to ensure electrical safety and the proper function of the grounding system. Always consult the latest NEC edition and local codes, and when in doubt, seek the advice of a qualified electrician.